Hello everyone, my name is Pradeep. I, along with my team members Abhishek, Rahul, and Jose, have worked on building a music recommendation system. In this project, we have designed, implemented, and analyzed a music recommendation system. We will discuss on various topics like problem statement, dataset overview, pre-processing, problems we have faced while implementing this system, methods we have implemented, results, and their analysis. Before moving on to that, let us understand what recommendation system is. So, recommender systems are pervasive. We all have encountered them either while buying a book on Barnes and Noble, or renting a movie on Netflix, listening to music on Spotify, or to finding the bar visit, etc. from Foursquare. A good recommendation system can help users a lot. The power of recommendation system is being harnessed by most businesses these days, from Netflix to Amazon, Google to Goodreads. Recommendation engines are one of the most widely used applications of machine learning algorithms. So, for instance, if I say I want to read a book, but I don't have any idea about what I want to read. So there's a wide range of possibilities how my search might pan out. So it's like I might waste a lot of time browsing around on the internet and just visiting various sites, hoping to see if I can find something really good and interesting to read. And I might look for recommendation from other people as well. But what if if there is a site or an app that could just recommend you the books based on what you have read previously or what the other users around you read? So instead of just wasting time on various sites looking through the books, I could just log in and there it is. Then some particular recommended books will be on my list. So that is the reason that this topic was chosen, because it's pretty basic to understand the recommendation system. We all face such problems in our daily life, and knowing our recommendation system really helps us in narrow down our choices. So the problem statement for this is that we all know that with the development of the mobile devices and the internet, it has all made possible for us to access different music resources freely. There are so many millions of songs that exceeds the capacity of a single individual. So, and we at times feel difficult to choose from so many songs. So, and moreover, music service providers now need an efficient way to manage songs and help their customers to discover music by giving them a highly quality recommendation. So there is a strong need of a good recommendation system for such companies, and music streaming services like Pandora, Spotify, etc. They constantly work on building a high precision commercial music recommendation system, and in turn they generate a revenue by helping their customers discover their relevant music, and they charge them for that service. So thus there is a strong thriving market for good music recommendation system. And basically music recommendation system is a system which learns from the user's past listening history and recommends them songs which they would like to hear in future. So keeping this objective in mind, the main objective of our project is to this project was taken from Kaggle Challenge, the WSDM Cup Box music recommendation, and where we had to build a recommended system that can predict whether a user will listen to a song again within 1 month after the user's very first observable event. If the user did not listen to the song again within 1 month, the target variable was set to 0, else it was 1. The dataset overview will be presented to you by Jose.
The dataset contains 7.3 million observations, each observation containing user information, song information, and event information. Though most importantly, each observation contains a binary target variable, which tracks whether a user listens to a certain song recurrently. This binary variable will later be used when creating our ratings matrix. As for data preprocessing, the data received was already quote unquote clean, and not much was needed to be done. All that was done really was rows with missing member ID numbers or song ID numbers were removed.
Hi, my name is Rahul, and I will be going through exploratory data analysis part. Uh, as we can see from this pie chart, that our main variable was the target variable. 0 was for no repeated listenings, while 1 was for repeated listenings, and they are in nearly equal ratio. In in this graph, we can see that listeners are more likely to repeat their favorite songs after saving it in their library. Moreover, the chances of a song being listened multiple times is high in case of Discover. In this graph, we can see that users listen more from their local playlist than from other sources, and the chances of repeating any song is quite high. Users also prefer to listen from online playlists, and the chances of listening songs only once is slightly more than the chances of listening repeatedly. Um, in, th- in this graph, we can see that source type is the screen where user first listens to any song, and over here too that users prefer to listen from their local library. Age variable was a bit tricky to handle as people don't usually give the right age in websites or apps. So if we were trying to plot all the age group in one plot, the problem that was arising is due to some outlier values like 0. We can see we have a huge number at 0, and again a lot of users must have given their age as more than 100. Because of such use cases, users who might have given their actual age were not getting shown up. That's why we split the whole age into three categories: 0 to 30, 31 to 80, and anyone above 80 as immortals. Moreover, most of the songs get listened by user group of 14 to 29, and users with age 14 to 16 seem that they have just started to listen songs. In this graph, we can see that the counts decline gradually after the age of 31. In this graph, we can see that we have data for age greater than 100 also, but the counts are quite low when compared with other age groups. This data might be incorrect too. Now, Abhishek will take over.
Hey, hi, this is Abhishek. I will be explaining the later part of the EDA. So, this is where we are actually explaining the variations of the songs with respect to the year. So, the song year where there was a huge collection of songs that we had in our data set starting from 1918 to 2017. And what we did saw is that there was a huge amount of popularity for the songs that are of recent year, which is quite understanding because people usually listen to the songs that are currently there in the currently popular. But there were also people who were listening songs which are quite old, like even dating back to 1918. So for properly visualizing the data, what we did was we split the data into like the songs prior to 1970s as old songs, and the songs that are currently there in the after 1970s to 2017 as the new songs. So this is the visualization. As you can see that for 2017 there is a huge bar over it, and it gradually declines as we are going back to the years. And for here we see that there is a sort of an erratic behavior when we are listening to the old songs. Going forward, we also try to visualize the variation of the target variable with respect to gender. We could see that there is a more or less equally divided information with respect to gender, which is not telling us anything about how to any information regarding the target variable. This plot was what we did to understand the variation, like understand the variation of repeated listen with based on the respective popularity, and we could see that there is some sort of a relation, but it's still a lot erratic and a lot of noise in it. It has a lot of noise in it, and you can see that there's a huge chunk of like information present for down below of the, like in the left hand side of the plot, and gradually declines, and as we go we can see a linear trend in it. This information was actually found by grouping based on the with respect to the song's ID and trying to find the like number of frequency or the count or the mean, and using those informations we were also trying to predict like what is the chance that a particular song, if it's popular, is going to be listened more, like more than once. Here we have again shown the variations of the target variable with respect to language. As you can see from the plot that there is not much information which this like the language variable on its own is carrying, but we would see that going forward language, like when it's like combined with some other variables, could show us some sort of information. The only thing that we can like actually gather from here is that there are 10 different languages that we are seeing here. This is again the variation of the target variable with respect to the genres, composers and lyricists. You could see that like there have been, like we have three different 3 x 3 9 different plots where each rows signifies, like the first row signifies the count of the songs, second row signifies the number of like the number of times a particular song is getting repeated, and the last one repeats the chance of it a particular song being heard more than once. And the column wise, if we say it, the first one is for the genres, second one is for composers, and third one is for lyricists. You could see that the count and the frequency plot are nearly like they are showing a similar trend in all the three cases with very little difference. But when we come to the third part, like the chance of repeated listen, there like we see there is a gradual trend where for composers and lyricists it's a bit noisy, like you cannot say that which one, like if it's actually following a trend or there is no such trend at all, because it falls down a bit then it goes up again. But in case of genres, we could actually see that there is a trend there, like for particular genres, there the popularity is high or the chance of repeated listens is high, and then for certain genres it's a bit low. That is very similar to how things are in normal life as well, with pop and rock cultures are having a much more popularity compared to some other genres. So as I was saying that the language variable was like it was having some information, but on the first look at it we didn't find any possible, like any significant information from it. But here what previously we were checking the variation of target count with respect to language, here we were checking the variation of songs popularity or the chance of it being listened with respect to language. Even here if you see that like there was no certain, or we could not say for a fact that there is a trend here, but we could see that like some languages were more popular compared to the other language, like songs belonging to a particular language were listened more than compared to the other language. And there was a particular language for whom the language type information was not present, so that was like null there, so we replaced it by -100 to actually visualize it, and we could see that there is a significant impact for those null values as well. Like we shouldn't, like we didn't remove these null informations because we saw that there was some significant informations being covered with them. Here what we did is that we based on the artist and the language, that is like that the songs are in for by or sang by the artist has been considered, and like we were really fortunate and we like were really surprised that see that there was some information that was being carried with this particular artist and language consideration, or combining those two information. And it could be like seen here that there is a some sort of trend that is being followed here, and there is a non-linear trend, we could say. If we like extend or extrapolate this information, maybe we would be able to visualize it better, but here we are having, like we can say that there is a trend here. And this is the long tail distribution that we kind of have shown here. This basically tells us that that the high frequency songs are more competitive and are like there is a more chance of them being listened or more than once or being repetitive. As additionally, this also suggests that certain amount of songs, certain amount of difficulty when providing recommendations of long tail, because as you can see that there is a huge rise and gradually it falls down. So if a particular song is in the tail region, then it's quite difficult to kind of recommend an information from that. So the EDA conclusion, as part of the EDA conclusion, we can say that as we already saw that genres have a quite like a very significant relationship for our target variable. Composers and releases, we could also say that has an information, but it was a bit noisy, and the frequency of of the song, the number of times we are like the number of songs being repeated for a lot of users or a number of users listening to a particular song, there is a chance that it's going to be repeatedly listened. And as we also saw that languages when combined with artists is also have a significant information, and songs length, which we haven't seen here, but we saw in our EDA part that a particular song's length is also like having an effect on its being listened, where like if a song is of average length being 3 minutes to 4 minutes, people tend to listen to it more than songs which are much larger, or we also like it. If I would be saying this, there was also a song that was 3 hours of length, and there was a song that was of just 1 second. So that was the variation that we had in our length department as well. Also, as an inference, we could say that since the data was a huge data set, there was a lot of noise in the data set. We tried to clean it, but we saw that if we are completely like if we clean it properly, then we would be losing a lot of information and data. That's why we didn't remove all of it, and we could find some kind of correlation, but yeah, that was noisy. Like we could you could see that we did get a significant output by from the recommendation system when Jose will be explaining it. And the next part would be like this is the recommendation system that we built, and it would be explained by Rahul. Thank you.
This is the music recommendation flowchart that we have followed. Initially, we have song and user data, and we converted it into rating matrix, and then we normalize that rating matrix. Uh, we can then do either item-based collaborative filtering or user-based collaborative filtering. We then recommend songs to all user accordingly. We also have case for cold start when a new user or a new songs comes in. If some new user comes, we then recommend him or her according to popularity based strategy, which includes top songs in that area or top songs in the year, and then store this new data in the song user table. If some new song comes in, we use content based strategy and recommend this song to old user or new user accordingly. Item based collaborative filtering is shown with weak arrow, as it won't be a good method for us here, as item set is quite huge, and user based collaborative filtering will be preferred because of low number of users.
Both user-based methods and item-based methods were considered for our collaborative filtering model. Both are viable options with their own pros and cons as listed in this table. For instance, in cases where there are many items, user-based methods might shine computationally over item-based ones and vice versa. A heat map of our item similarity matrix was created, in which a cosine correlation is used. Likewise, the following is a heat map of our user similarity matrix, in which a cosine correlation is also used. The true positive rate is plotted against the false positive rate, and by inspection, it is clear that user-based methods outperform item-based ones in our context. It is also worth noting that user-based methods are comparable with popular item-based methods. As expected, random recommendation methods perform poorly. When plotting precision against recall, Like before, user-based methods outperformed item-based ones, and again, user-based methods are comparable with popular ones. When creating these recommender systems, some of the challenges we faced was mainly caused by size. Processing such a huge data set can get computationally unruly on the memory and the CPU. Additionally, metadata includes huge amounts of information, and when exploring it, it can be difficult to extract relevant features for a song. In practice, we randomly chose a user who recurrently listens to Toxic by Britney Spears and applied our recommender system to assess their top 3 recommended songs. Our system recommended more contemporary pop songs to what the user was used to. Recommended songs included Closer by the Chainsmokers as well as contemporary Asian pop songs such as Hereafter Us by Mayday. To conclude, it can be noted that user-based collaborative filtering outperformed item-based methods. This makes sense in this context since we do have a quote-unquote fat ratings matrix, and in the future, I think we should consider hybrid methods as well as develop recommendation for different types of ratings. For instance, different ratings based on how the user is feeling or social recommendations. These are our references. Thank you for listening.